Good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today, I am going to deliver you lecture number 4, that is about methane oxidation. We are studying a special paper of physical chemistry. General mechanism. Methane is an important particle fuel which constitute methane is important practical fuel which constitute about 90% of the composition of natural gas. The mechanism of methane and oxygen involves 22 steps and at least 12 species depending upon temperature and pressure. The methane oxidation is a branched chain reaction which initiated by following two reactions. These following two reactions are first important for the oxidation of methane. First reaction is hydrogen abstraction reaction from methane by oxygen. In equation number 1, we can see that CH4 reacts with oxygen and one oxygen hydrogen atom is attached to the O2 and form HO2, and CH3 is converted into CH3 free radical. And second reaction, important reaction, is a collision induced dissociation of methane. Methane can be dissociated two way by abstraction of hydrogen from methane, and second is its collision with collision or dissociation induced by some other external material. So CH4 combines with M to form CH3 plus M. This is reaction number 2. These two reactions are important. The thermal carbon hydrogen bond fission described by equation 2, in which carbon and hydrogen bond is breaking, is slower for CH4 than for any other hydrocarbon. जो CH4 में से H बॉन्ड ब्रेक होता है वो जो बॉन्ड है ब्रेकिंग, ये जो प्रोसेस है ये स्लो होता है किसी और हाइड्रोकार्बन से, क्योंकि और किसी हाइड्रोकार्बन का बॉन्ड स्ट्रेंथ CH4 के कार्बन हाइड्रोजन बॉन्ड से कम होती है, because the carbon hydrogen bond in CH4 is stronger than that of the most hydrocarbons. Next point which is important is, as a result of hydrogen abstraction from CH4 by radical like H, O, OH and HO2, the following are propagation steps. First two are initiation steps, and second this now next step is propagation step. In this we species H, O, OH and HO2 can abstract hydrogen to form new radicals. So CH4 reacts with H to form CH3 free radical and hydrogen. CH4 combines with oxygen to form CH3 free radical plus OH. CH4 combines with OH to form CH3 free radical and water. And CH4 combines with HO2 and forms CH3 and H2O2. In all these reactions, H, O, OH and HO2, they are propagating the step. Next step है the methyl radicals occurred by their reactions are oxidized to formaldehyde. The methyl reaction which is formed or which is prepared, which is produced in these reactions, they are oxidized to formaldehyde HCHO या CH2O and formyl radicals HCO, ठीक है, and eventually from CO accomplished by the reaction of methyl radical with oxygen and oxygen atom and oxygen as follows. CH3 free radical combines with oxygen to form CH2OH. CH2O formyl, है ना, formaldehyde plus H. CH3 react with what? Oxygen molecule to form formyl radical CH3O and oxygen. Then CH3 combines with oxygen to form HCO and H2O. These new species, which are H2O, CH3O and HCO, also participate in following manner. CH3O combines with oxygen to form CH3 radical and oxygen. CH3O react with oxygen to form CH2O and HO2. CH3O combines with M to form CH2O plus H plus M. CH2O combines with oxygen to form HCO and OH. CH2O combines with H to form HCO plus H2. CH2O plus M combines to form HCO plus H plus M. Similarly, HCO combines with oxygen to form ultimate reaction CO and OH. And HCO plus HO2 again forms OH, CO and H2O2. It is clear that once methyl radicals are produced, they react to oxidize the final product carbon monoxide. The same oxidation process is terminated by the following step. These are the propagation steps and this is the termination step. H reacts with OH and M to form H2OM. HCO react with OH to form CO and H2O. HCO plus H combines to form CO plus H2. Thus, the net reaction mechanism for methane oxidation is given by CH4 plus 1.5 oxygen, giving you carbon monoxide and 2 water molecules. The reaction is exothermic with 543.8 kilojoules per mole of the reaction. Today we have studied oxidation of methane. In the next lecture, we will study the low temperature oxidation of methane, which has a different mechanism. Okay? So we will study it later on. And thank you, students, for today's lecture.